All right, so I stopped at 18, I think, last time. Yeah, that's where I am. The value of log base 3 of 27 is what? So perhaps you should write this. I don't know. Write what power of 3 creates 27? And the answer is 3 cubed. That's how hard those are. A lot of kids will miss that. All right, find the horizontal asymptote and vertical asymptotes of the following. So let's start with the HA. There were 3 rules. There was rule 1, if the power of the numerator is greater than the power of the denominator. Okay, for example, x to the 4th over x, there is no horizontal asymptote. Doesn't exist. What's the other one? If the power of the numerator is equal to the denominator, and for example, 3x to the 9th plus some crap over 2x to the 9th plus some crap, then it's just C over A, or sorry, A over C. This would be 3 over 2. I don't remember the formal math speak on these things. And the last one is if the power of the numerator is less than the denominator, it is always y equals 0. So let's look at this one. I have x squared over 3x squared. So that's the last case. These cancel, and I get 1/3. So the horizontal asymptote is 1/3. It's one of these two. Now the vertical asymptotes happen after simplifying where I attempt to divide by 0. So this thing probably factors. What we got? We got a -2 and a +1, so x plus 2, x minus 1. Down low takes a 3x and an x. Factors of 20 are going to be 4 and 5. 4 times 3 is 12. No, not 4 and 5. It's not in that order. 5 and 4, no. 10 and 2. Yeah, 10 and 2 she is. 10 and 2. Let's see, we'll need to do -10 plus 6. Now I would attempt to divide by 0 right here. 3x minus 10 cannot be 0. So 3x cannot be 10, and x cannot be 10/3. There's your vertical asymptote. Not too bad. Really not. You got 3 rules to memorize, and you got to know how to factor. Find the oblique asymptote of this function. The oblique asymptote is the quotient from long division. It won't be too bad. It'll be x something. Nope, I did that backwards. Let's see, inside is going to be x cubed. I'm going to put plus 0x squared plus 0x minus 1. You could actually, no, you couldn't, never mind. You could, if you know what you're doing, do synthetic division on this one. Because, no, you can't. I'm wrong. Anyways, it takes an x to become x cubed. So x times x squared is x cubed minus x squared and then plus x. And we wrap before we subtract. X cubed minus x cubed is nothing. 0 minus a -1 is going to be a singular x squared. 0 minus 1 is going to be minus x, and we bring down. And Anyways, it's gonna take a 1 for that x squared to become, no, yeah, I just need a 1 because I need another x squared. 1 times x squared is x squared minus an x plus a 1. And again, we wrap before we subtract. And 0, 0, -2, which is a remainder. If they were smart, they would put that there. But this is your slant asymptote. X plus 1. Choice B. Find the domain of this function. It's probably got more than one piece. I can glance at it real quick and I can tell you that 2x plus 8 cannot be 0. And actually, that's the only issue. We don't divide by 0. Ever. So 2x cannot be -8 and x cannot be -4. Now, they talk about what this thing looks like on a graph. Well, no, they don't. All that matters is that x is not -4. You know, think about your mom functions for these things. The mom function. What is something like, oops, there's something like that. Ignore that little guy. The only issue you have is wherever you have the vertical asymptote. So everything but -4. Inequalities. Honestly, you could just plug in numbers on this thing. I mean, you could. It's not a bad skill. Let's do this. Let's do a plug in numbers. Plug in numbers. So halfway between, something between -infinity and 1 is 0. Something between 2 and infinity is 3. So I'm going to test 0. Now, by the way, there's a reason there's no bracket on that. If you plug in a 2, the world ends. Now, if I plug in a 0, I would have 1 over -2 plus 1 greater than 0. That's true. That is true. That's going to be 1/2. If I plug in a 3, I don't want to plug in a 2, but if I plug in a 3, well, I'm going to have 1 minus 3 over 3 minus 2 plus the 1. Is it greater than 0? That's going to be -2 over 1. This is false because this is -1 plus 1. It's not greater than 0, it's equal to 0. So I'm throwing away that piece. So it's going there, it's going there. So I've made it down this far. This one makes no sense because I could be 0, gone. So that leaves -infinity to 2. True. Number 3 failed. There you go. Plug in numbers. Hopefully what I did makes some sense. There's my lunch break. That's how much I love y'all. It is my lunch break. 23, solve another inequality. So let's just do this one by hand. Do it the way we're supposed to, other than plugging numbers, and we'll check them, see if the numbers make sense. But we can factor as what, +4 and -2. We're looking for less than 0. Our critical values here are -4 and +2. We don't have equality, open hole, -4. We have equality at 2, open hole. And we're going to have to do some testing here. We're going to have to, plain and simple. So let's test the easy guy. Let's test 0. 0 squared plus twice a 0 minus 8 less than 0. That's true. So I get to keep everything inside, which tells me the answer is most likely B. Let's test something to the left of -4. Let's test a -5. A -5 squared plus 2 times a -5 minus an 8 less than 0. This is 25 minus 10 minus 8. That is false, so all that. And now let's test a 3. This is probably going to be thrown away too. It was a really simple one. But just because this is simple doesn't mean the one that you do might not be. I hate it when you find an answer off the bat and kids tune out, but it is what it is. So we're going to test a 3. That'd be a 3 squared plus twice a 3 minus an 8 less than 0. You know, that's 9 plus 6 minus 8 less than 0. That's false. So all that too. The only thing that mattered was the stuff between -4 and 2. That's it. They should have at least put one answer choice in brackets. If I remember right, this is from some place in California, so boo to you. All right, 24, solve this equation. Boy, it'd be sweet if you had a TI-84, wouldn't it? We have 3 to the 2x squared minus 5x equal to 3 cubed, because 27 is 3 cubed, and now we drop those. We set those two pieces equal. 2x squared minus 5x is equal to 3. We jump the 3 over. 2x squared minus 5x minus 3 is 0. We factor because we are little factoring creatures. Let's see, here do I want to factor you? I need a -3 and a +1. Yay, nay? I think that's a yay. Use that zero product property. X is -1/2 or X is 3. Looks to me like that's choice C. Convert the equation 2 cubed equals 8 into logarithmic form. Let's see what we have here. We have a base, we have an exponent, and we have an answer. And I know that log is big. So this is going to be a log whose base of 2. Our argument's going to be 8, because that's saying what power of 2 creates an 8. And the result of that is 3. 26. If a certain amount of money is invested in a bank account at an interest rate of 8% per year compounded continuously, how many years will it take for the money to double? The value of t lies between what and what? Interesting. You probably will not see this. The reason I say that is because it doesn't apply to you, but this is PERT. It is PERT. And, you know, you're going to just invest $1. So the amount after some time passes. Oh, by the way, the goal is to get 2, isn't it? It's going to double. So after some time, let's just say $1. After some time, you have $2. You'll say 2 equals 1e to the 0.08t. And like I said, this does not apply to you. It doesn't. Well, what we would do is we would ln both sides. What does apply to you is being able to write it out. Writing it out does. The natural log of 2 is equal to the natural log of e to the 0.08t. We move that out front. The natural log of 2 is equal to 0.08t. Sorry, 0.08 ln's of e. T times, make that a big time symbol, times ln of e. The natural log of e is 1, so we just throw it out. And the time is going to be the natural log of 2 divided by 800ths. Now that does apply to you. That does. You're probably curious what the answer is. I don't know. I'm a little curious. It's gonna be, I would say, if I was guessing, if I was a betting man, I'd choose either D or E. I'm just not feeling it today. I can't tell you what the natural log of 2 is today with any accuracy. It's probably like 0.8. 0.8 divided by 0.08. Yeah, I'm thinking it's probably choice D. Oh, I was wrong. It's choice C. Oh, anyways, know how to do that. You won't have a calculator to push buttons on, so know how to write. Ah, the condensing into a singular logarithm. These are really, really simple. If positive, numerator. If negative, denominator. And you remember your rules about these two. All right. So let's talk about my positive stuff first. There is a 2a. There's a 1. Interesting. What power of a creates a 1? That's actually 0, by the way. But anyways, it doesn't matter. There's a 1. There's a 16 to the 1/2 power. And down in the bottom is an a. Isn't that interesting? That's very interesting. Now, I want to talk about this first. What power of a creates a? And the answer to that is 1. So I talked about some stuff here, but there's some little things. So let me look at this from a rewrite point of view. The power of a that creates a 1 is 0. So this is actually plus 0. This one's fine. This is 1, so minus 1. Kind of interesting how this thing's working out. That's an interesting looking feller there too, oh, isn't it? All right, let's see what happens. These two can be put together. 16 to the 1/2 is 4. I'd have log of 8a, and this is base 8. And then I have minus 1. I feel like there's a typo made on this thing. Oh, Milbrath being dumb. Maybe I should have, I went too far. The a's cancel, don't they? So ignore. All you're left with is 2 times 4. Log base a of 8. All right, went too far. Shouldn't have done that. Ignore. Was thinking about something else. I apologize. I thought they were trying to trick you. This must be a community college test. Convert 140 degrees to radians. Oh, Lord help you if you miss this. I will haunt your dreams for the rest of your life. Just sitting there going, shame, shame, shame. Multiply by pi over 180. Degrees, obviously. The zeros and the degrees cancel. So 14 pi over 18, and those are both even numbers. 7 pi over 9. Find the exact value of the arc cosine of negative 9 pi over 4. Now, I don't know if you remember this or not, but remember coterminality? You can add or subtract twice pi, or add and subtract 360 degrees. You can do one of the two. It's really up to you. You know, you can take Old Faithful here. It's kind of hard to see, but I know that pi is 180 degrees. So let's do 180 divided by that 4. I get 45, and then I multiply it by that negative 9. I can't really do the negative key on this thing, but it's negative 405 degrees. So I'm really finding the cosine of negative 405. And let's add 360 to that, and I'll get the cosine of negative 45 degrees, which you can draw, or Maybe you remember this idea, the cosine of a negative angle is the cosine of a positive angle. It's really up to you. You can do either or. I'm just gonna go with negative 45 degrees because it's easy peasy. I rotate negative 45 degrees. I draw in a triangle. Maybe I think about the unit circle. Remember unit circle? Remember her? I'm just not going to draw her right now. I happen to know the 45, 45, 90 pattern. It's 1, root 2 over 2, root 2 over 2. Direction matters. That one's negative. And I want the cosine of this angle, and the angle would be right here. From SOHCAHTOA, the cosine of negative 45 degrees is going to be adjacent root 2 over 2 over the hypotenuse. So, those tricky little things, man. 1 over root 2. Because root 2 over root 2, I get root 2 over 2. Evil little fellers, aren't they? What they're doing, whoever designed this class or in the state of California, they probably taught their student body to do 1, negative 1, root 2. So adjacent hypotenuse. That's fairly common to use that pattern. Find the angle coterminal with 17 pi over 3. And again, I'm just going to replace that with 180. So 17 times 180 is 3060, and then I'm supposed to divide it by 3. 1020. Now, I know I can take away from that a couple times. Coterminality is add or subtract 360. If I take it away once, I get 660, which doesn't look, this is, no. Don't be that kid. Don't be that kid. Take it away again, I get 360, which is 300. No, don't see it. Take it away again, I get negative 360, and I see my winner. This is negative 60 degrees. Choice B. Find the cosine of twice theta if the sine of theta is negative 3/5. Now you get to use your formula sheet. I don't have one on me. I think I've got it up somewhere. I was just looking at it earlier. Apparently not. Okay, give me a moment. Pre-calculus formula sheet. There she is. So what am I using here? Find the cosine of twice theta if the sine of theta is negative 3/5. So I'm looking at that thing that says cosine of 2t. And it's simply cosine squared of t minus sine squared of t. I'm looking, kids, boys and girls, if you're playing along, at this guy right here, okay? That's what I'm looking at. All right, back to my camera. This will be the one I stop at. I know the sine of theta is negative 3/5. I know that all strippers take cash. And I know that I can draw. Sine's going to be negative in one of these two quadrants. Doesn't really matter which one I pick. The rest of it's going to take care of things. I'm just going to go with this quadrant for absolutely no good reason. I would need to fall 3 and have a hypotenuse of 5, adjacent length of 4. So with that triangle, I know that the cosine of theta is 4/5. Really wouldn't matter which one of these you put in because squaring makes things positive. So the cosine of twice that angle, in this case theta, is going to be the cosine ratio of 4/5 squared minus the sine ratio of negative 3/5 squared. 4 squared is 16, 5 squared is 25, 3 squared is 9, 5 squared is 25, 16 minus 9 is what? 7? 7/25. Choice B. That is where I stop from now. That way I can go to little boy's room.